So in this video we shall continue to learn about the simple pendulum, in which we will explore how the time period of a simple pendulum is affected by the mass of the pendulum bob, the amplitude of the pendulum, the effective length of the pendulum, the acceleration due to gravity. Now when we look at all these factors, we are considering that the air resistance that the pendulum faces is zero. In other words, we are considering the pendulum to be swinging in vacuum. So let's look at the first factor, and that is the mass of the pendulum bob. So here you can see that the pendulum on the right has a bigger bob of greater mass, and the one on the left has a smaller bob of lesser mass. However, contrary to our expectations, we find that both the pendulums actually swing with an equal time period. Now that means that the time period of a pendulum does not depend on the mass of the bob. Next, let's look at another factor, and this time it is the amplitude of the pendulum. Now here, the pendulum on the left has a greater amplitude compared to the one on the right. However, we find that both the pendulums swing with an equal time period, which means that again, the time period of a pendulum does not depend upon its amplitude. Now this applies only when the amplitude is very small. Next, let's look at another factor which is very prominent, and that is the effective length of the pendulum. Here we see that there are two pendulums of unequal effective lengths. The one on the left is longer and the one on the right is shorter. And as expected, the one on the right actually swings faster. It has a shorter time period compared to the one on the left, which means that the time period of a pendulum depends on its effective length. If we measure the time periods of pendulums whose effective lengths are from 30 centimeters till 100 centimeters, we get to see that the time periods increase with the effective length. And as we plot these values on a graph, the graph looks like this. Now, we don't get to see any mathematical relationship between time period and effective length over here. So what we are going to do is that we will consider the square of the time period. And the graph of t square against L is a straight line that slopes towards the origin. Now this means that t square is directly proportional to L. In other words, it also means that t is proportional to the square root of L. So that is the relationship between the time period of a pendulum and its effective length. Next, let's look at the acceleration due to gravity. Now here we have two pendulums. The one on the left is on the earth, where the acceleration due to gravity is 9.8 meter per second square, and the one on the right is on the moon, where the acceleration due to gravity is just 1.6 meter per second square. See what happens. The pendulum on the moon is very slow compared to that on the earth. This means that the time period of the pendulum on the moon is higher, where the acceleration due to gravity is lower. And this means that there is an inverse relationship between the time period and the acceleration due to gravity. And the correct mathematical relationship is t is inversely proportional to the square root of the acceleration due to gravity g. Now we have two relationships. The first one is the relationship of the time period t with the effective length L, and that relationship is t is directly proportional to the square root of L. The other relationship is the relationship of the time period t with the acceleration due to gravity g. And this relationship is that t is inversely proportional to the square root of g. Now when we combine both these equations, we get another equation, and that equation is t is equal to 2 pi under root L upon g. So this is the equation that we are going to use to solve numerical problems. But for now, let's have the summary of this video. A pendulum's time period does not depend on the mass of its bob. For small values, a pendulum's time period is independent of its amplitude. A pendulum's time period is proportional to the square root of the effective length. A pendulum's time period is inversely proportional to the square root of the acceleration due to gravity g. And for any pendulum, the time period is given by the equation t equals to 2 pi under root L upon g. So that's all in this video. In the next video, we're going to learn how to use that equation to solve simple numerical problems pertaining to the simple pendulum.